My subscribers, come again. Your Mr. Wallet. So you can see my system. Um, Here is my 12-volt DC motor. It is a brush motor, so it can run clockwise, anti-clockwise when you change the terminal, when you change the polarity. Here is my 12-volt DC motor, 7 amp. Um, so I'm gonna use it to run the generator. Um, the experiment I want to carry out today is this is one of the modified statue I did uh, early last year. So it's one of my modified generator. I have already modified before, so but this one is the one that is currently available. So I want to experiment, like some people ask how I modify the generator to give me high voltage. You know, when modifying generator to give you a high voltage depend on your desire, the project you are using it to do. So in this setup, this is modified generator. I use my hand to modify. So and when you check here, this is a unmodified, unmodified stator generator. This is a company wind. So you can see how it is. This is unmodified. So but this one is modified. So it has a 4 terminal. This wire is for 220 AC output, while this one is for exciter. This is a heat capacitor, 24 UF microfarad. So now we connect it here, then run it here to see the output. So in this experiment, I'm not intend to put any load because the output from this startup is too high. So any load you put on it, it will damage it because the voltage is more than 220 volts output. So you can see how the alignment is. The alignment, there is no any screw here, there's no anything here. So because the motor uh, can, when you rotate it anti-clockwise, the shaft is pulling out. So you can see it is pulling off. It's pulling off here. It is pulling off here. So but when you rotate clockwise, it's lock. Yeah, it is tight by itself. So that's how the system is. You can see. So it's pulling out. It's pulling out. I'm locking it now. It is rotating with the motor shaft. It's rotating with the motor shaft. But when you rotate it this way, the motor shaft is not rotating. You can see, motor shaft is not rotating. So that's how the mechanism I use to do it. But the other, my previous, I can use to my screwdriver to lose it. So now I'm gonna test it. So this is my this is my voltmeter. So I'm gonna connect it. Let me connect it for the AC terminal. It's pretty much. So now this is exciter wire, the yellow wire. So let me connect it to the capacitor. Now I'll make the connection. So when you come over here, this is the motor, my 12-volt DC motor. So like I have already said, you can see the shaft is tight. So now the the this is the positive terminal. Then if I join this positive terminal to this negative of the battery, the motor will rotate this way, which they shout. It will it will engage and disengage. So how I do is like when you rotate anti-clockwise, it will disengage with the generator, but when you rotate clockwise, it will engage. So it's like a crush. It's like a crush. So let's experiment with it. This is the positive terminal going in the negative terminal of the battery. So the negative terminal going to the positive. You can see it has disengaged. The motor is rotating, but it's not turning the generator. Now let me reverse the polarity. Let me reverse the polarity. You can see the motor is rotating with the generator. The motor now is rotating with the generator. Let me reverse it again for you to see. You can see the motor is disengaged. It's like a clutch. The motor is disengaged. Then let me connect it again. It has now locked. So it has engaged. So now so let me bring it up. So now this is the meter here. Then this is the generator. So now I'm gonna run the system to see the maximum voltage. I think the previous one I want give me almost around 700 or 800 volts. So it got my meter damaged because uh, the maximum volt this current meter can read is 700 volts. So anything more than that, either this meter got burnt or it will start misbehaving. It won't read accurate again. So let me run the system. Okay. 381 volts. 381 volts. So that's what the motor gave me. So 381, 82 volts. So, so you're seeing the huge amount of volts it gave me. So any load we put on it now will be damaged. Will be damaged. So now I want to we pull this stator off. Then I will show you the size of the wire I used to wind it and how many turns per slot. So okay, now let me do it now. Now I have to uh, disengage this motor. I have to disengage it by reversing the terminal. So I have to do it by reversing the terminal so that I will dismantle the generator. It has locked. So let's do it again to know if he okay. So we have disengage it. So now I will put the generator off. Yes, put the generator off. Disconnect the capacitor. Hmm. Let me apply some heating. So let me heat it from. So this is the Lotto diameter. So now this is the the stator. So you can see. So now I will pull the wire off. Then I will use my this caliper to measure the size of the wire and the turns. I will count the turns so that you see the turns per slot. So I have to dismantle it. So let me dismantle it. Okay, now I have successfully put the I used to guide the coil so it won't scatter and interact with the lotto. So I pull it off. Now I will have to remove one of the pole this slot so that you count the number of turns. So you can see the winding. So I have to uh, pull one slot here. I have to pull one slot there. I have to count it to know the number of turns and the wire conductor size. Remember, this is copper. Like I told before, I don't make use of aluminum. So this is copper. So now I have to pull the I have to pull the insulator. I have to pull the insulator off. How do I do that? I have to pull the insulator off. I've removed the insulator. Let me remove this one. Okay, so you can see I have successfully removed this insulator of this one. So I have to pull it out now, so that I have to carefully pull it out. I have put this side off. So let me put this side again. So I want to it, be careful to avoid scratching the coil or scratching the enamel insulator. So now I have pulled it off. I have pulled it off. So now let me show it. So let me show from here so that I will count it properly. So now you can see the can see. So now let me lead the wire conductor side. Let me lead the size to know the conductor. So this is my clamp meter. Okay, so now let me straight the wire. Make sure it is straight so that it will give me accurate. 0.6. So 0.6 0.6 mm is what I use to wind this generator. Like I said before, I use 0.6 mm. Normally, what they use to wind this status tiger generator, small generator is either 0.6 or 0.7. So now, I want to count the tons to know the how many tons per slot. So let me observe it very well. Okay, let me count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 88, 81, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 1, 2. Oh, you can see 102. 102 is what I use to wind the generator. So that's why it give me the other one. I think I wind I think 115 or thereabouts. So it give me almost 700 volts more than that. So you can see. So that is how I wind it. Then the finishing will be connected. So it's a series connection. So this is the exciter. This is that I use a tape to insulate it to avoid the touching with the mains. So you can see the exciter here reading the capacitor. So you guys, we have seen the number of turns. That's why it gives me a high voltage. If I increase the value of this capacitor, I may be getting something about 500 volts or more. This is 24 UF capacitor. So if I can increase it like 30 UF, 40 UF, or 35, I may get close to 500 volts. So, but you see this stator winding, it is unmodified. So if I run this one, I may be getting something about with this the same value of capacitor. I may be getting something about 140 volts or 180 volts, or later is let's say 200 volts. So with the same speed, um, the same value of capacitor connected. So, but modified one is giving me almost 381 volts, going to 400 volts. So I wind it, but I later recognize, though it depends on like this generator is suitable, like hydro system. Maybe you can fabricate the armature uh, as a permanent magnet, then so that with the rotor running, it will be generating a high volt. It's a rotor running, it will be generating high volt. This winding is like times two because this one here, this company winding, when you check it from, I think each slot here is I think 40 tons or either 40 tons or 50 tons. So it's like half of this. So when you check this, it is like either 40 something or 50 tons maximum. So, but I could be able to put um, more than 100 tons per slot. So this system is suitable for wind turbine, which charge controller will take the excess voltage and maintain it. And assuming you are using MPPT, so it will help the excess voltage convert it to current, then fast charge your system. It is suitable for wind turbine or hydro plants. When you have a running water, can structure the make it permanent magnet instead of electromagnetic, whereby you won't need any capacitor. So, but in this system of fuel generator, which there's no any regulator to handle it, you will get high voltage, and putting any home appliances will get it damaged because the voltage is too high. It has damaged a lot of my appliances, my heater due to the high volts. So controlling this output is um, very complicated because any mistake will lead to a lot of damage. Understand? So when you want to modify, just by adding, assuming you are using this generator and you are getting let's say 180 volts, you can add some tons. You can add some tons here. Maybe if per slot is 50, maybe you can add 55 per slot. With that, when you accumulate it, you may be getting 230 or 240 of votes. But when you modify it without checking, balancing it, balancing the exciter, balancing the mains, you may get high voltage or you may get low voltage. So winding this generator is somehow difficult, and you have to calculate it. You have to calculate the exciter winding. You have to calculate the exciter, the mains. So because when you wind the exciter high turns, it will lead to high voltage. So when you wind the mains high turns, it will lead to high voltage. So both work hand in hand. So every modification has its best calculation, best system it will use. Like this generator now, it is suitable for hydro and wind turbine because it doesn't need much speed. It's a system that doesn't require much speed. So any rotation, it will generate a lot of power. But if you use this one, you have to have a high speed, maybe gear up system, so that it will meet up with the speed because it has a low tons of wire. So um, I hope you learned something from this experiment. So if you want to increase your tons, do it calculately. Do it. You have to calculate it. You have to balance it from the exciter to the mains. So I use in this system this stator. I use 0.6 mm and I could be able to wind more than 100 tons per slot. So thank you for watching. If you have a question, feel free to answer. Then if you want to support the program, feel free to do so. Thank you.